Hello everyone, welcome to pipeengine.com. Today we're gonna have another tutorial video focused on HDD. This particular tool was developed to help the engineers, designer to plan for the pullback operation for HDD. We all know that the pullback is probably one of the most important steps for HDD. Does require a lot of planning in terms of the equipment selection, how many cranes, how much workspace we'll probably need, how many rollers to support it, and whether or not we have enough space. So this tool is intended to help the engineers and designer do a quick calculation to figure that out. So let's quickly dive into the tool itself. Again, all our tools offered on our website, we do have imperial units and metric unit selection for users in the US or outside. For this tutorial video, I'm gonna just use the imperial units. And the first section is really just focus on the pipe spec inputs. We have this kind of a drop-down menu for a lot of our tools. It's very fairly to use if you have like a standard wall thickness, and you could just put the drop-down to put it, different size. And then same thing for the schedule. They have all the typical standard schedule available. But if you do have the pipe wall thickness and size different from standard, you just go to the drop-down menu, select the custom, which is the first one, and then you can trigger this manual inputs for your pipe spec. So in this case, we can just keep it a custom. We can just generically say it's 24-inch outer diameter, and we can say just 0.75, for example, right? And here, same thing for the grade. It could, typically in the US we use an API, a 5-file pipe. In Canada, we have a CSA grade. So here is the quick drop-down menu for you to quickly select the grade. So in this case, we're gonna go for X52. If you have a custom pipe grade overseas, for example, you could choose custom and manually put in the specified minimum yield strength. So in this case, we select the 52. Of course, the slice is going to be 52,000. And then the following, we have a few typical values. Again, this are all the typical values used. You could use rely on just to keep it unchanged to use the typical values. Or if you prefer to change it, for example, for elastic modulus of steel pipe, some places they use a 30 instead of 29, so you could just click and you can override the value here, or you can just keep a default value. Same thing for the weight of pipe materials. This is a standard typical carbon steel density. If you have a preferred value, you can click and update the value here. So this is unit weight of fluid in pipe. So in this case, we could pull back without water ballast, but if you have water ballast, you could put that in. And here is the maximal bending stress between elevated support. So the default of our tool, we assume is going to be 30% SMICE. But if you prefer to use a lower or higher value based on your separate independent calculation, feel free to do so. Again, you just need to tick the box and change the value here. Same thing for factor of safety, and typical values between 2 and 5. If you want to go more conservative, you could put it 3.0. You could go to be 4.0. But the default is gonna be 2.0. So based on the inputs, this tool is gonna calculate basically the pipe stress conditions and really obtain some key parameters, which is Um, really, the maximum allowed spacing between supports. This means um, the roller supports, and also this is the maximum allowable spacing between elevator supports. This means the crane supports, and also the minimum allowed roping radius of pipe. So that's the radius when you lift the curvature section of the pipe for your crane. So your minimal radius has to be more than the calculated value. And it's come here because we changed the factor of safety, everything. So the roping radius right now is it shows is the input is not enough. And so you have to change this to over the calculated 16. Let's say we keep it 1700, for example. And then you probably look at let's go back to the geometry inputs here. So the exit tension length is the tension length we have for the straight run at the beginning of this lift. Again, 15 foot is a recommended typical value. I think unless you are sure, I would recommend just keep 15 foot. And if you want to change it, same thing, just tick the box and change the value. So and then the roller height is really how high is the roller. So in this case, I put a 4 foot. You could have put a 2 foot if you want to keep the pipe a little bit lower. So that's going to change the overall geometry of this pullback. This graphs really show you the calculated distance from everything. So for this particular graphs, we assume there will be pretty much 3 cranes used. You could potentially use more, but for the calculation purposes, we assume there would be 3 of them, which is going to be defined as A, B, and C, because as you can tell, the definition have different parameters. So estimated height of lifting point A, lifting point B, and then the exit angle. This is gonna be the angle for your HDD design. So in this case, I put in an angle. So here is a whole bunch of criteria you're gonna go through. Pretty much just show the calculation results of these key parameters. And as you can tell, probably here we have a few like an internal criteria check. One is the distance from exit to the point. So all this lifting point has to be less than the calculated maximum span. So in this case, for example, the distance, because of geometry, we put it in the radius. Say distance from the exit point to the lifting point between is larger than the max. So there's a few things we could do to change this, as meaning for the roping radius. But for this case, because we use a fairly conservative safety factor and all this becomes not possible. So in this case, we will need to consider adding additional crane in between to make sure the spacing is less. So the default, like I said, the default is 3 cranes, 1, 2, 3. But in this case, we probably need to consider adding more cranes in between to make sure the spacing requirement between the lifting point B and C has to be less than the maximum calculated spacing, which is going to be which is 149 foot. So that's kind of how you use the tool to plan how many cranes are going to be on site, and also this will also give you the maximum spacing for the rollers. So the maximum is going to be 70.3 foot. So you typically would like to add some contingency on that. Probably set up the spacing as a 50 or 40. So you can get how many rollers you will need based on the total pullback length. that's the calculation part really for this tool. And you could, like all our tools, you could choose to save this calculation and on the cloud server, or you can download as a local file. You could choose open to open this local file, and lastly, you could choose to generate a PDF report to summarize your calculation. So that's pretty much everything related to this tool. If you have any questions, feel free to reach out to us. And thank you so much.